Okay, this is number 7 on the sample final. It asks you for the molar mass of a gas. It gives you volume, temperature, and pressure, and it gives you the mass of the gas. This should right away be obvious to you. It's an ideal gas law problem where PV equals nRT. The key step here is realizing that you can express moles as mass over molecular weight. Remember, molecular weight is the same thing as molar mass. If that's still confusing to you, remember mass over molar weight, which is just usually grams per mole, so that equals mole, which is what N represents. So we can rewrite the equation and say PV equals mass over molecular weight times RT. If we solve for molecular weight, let's multiply molecular weight by both sides. That gives us molecular weight times PV equals mass times RT. Now we'll divide PV by both sides to isolate molecular weight by itself. That gives us molecular weight equals mass times RT divided by PV. So now we just straight plug and chug. We have all of our information up here. Here's our volume. It's in liters. It needs to be in liters. Here's our temperature. It's in Celsius. We need to convert that. Conversion is 273 plus 63 will give us our Kelvin temperature, which is 633. Now, Dr. Radcliffe's class apparently uses 273.16 when they convert Kelvin. My course only uses 273 by itself, so we go to 336 Kelvin. We have our atmospheres right here, pressure, which is in the right units, and we have mass. So now we just got to plug and chug it. Remember, we're using this equation right here. So our mass, 17.07 grams. Now make sure to write your units and be careful. R, 0.08206 liter atmospheres per mole Kelvin. Temperature we just said was 336 Kelvin. Now we're dividing by P. Our pressure was 0.593 atmospheres. And our volume, it told us, is 4.69 liters. So now, when you write your units and you be careful, you go back, you cancel them out, and you can see if you did the problem correctly. You cancel atmospheres, cancel liters, cancel your Kelvin. You're left with grams per mole, which is what we're after. You're going to have 3 sig figs because of your atmospheres and your Kelvin. That leads us to the answer. If you punch in your calculator, you should end up getting 169 grams per mole. Now, If you're smart, you would have already written grams per mole on your final exam before you even got to the problem. If you do that, you can't possibly forget your units. If you get there and you don't put an answer in there, it's wrong either way. So make sure you have your units in there. Avoid those careless mistakes. So this is sample final number 7.